there is really a jungle of programming paradigms out there. In this course, we've seen a few paradigms in a well-organized way, but in fact, in practice, many, many paradigms are used, several dozen. So here in this picture, I show you these paradigms, some of them. Some of them you know, active object-oriented programming. But what about relational programming? What about event loop programming? What about object capability programming? What about lazy functional programming paradigms that we didn't see? What about lazy constraint programming? What about concurrent constraint programming and functional reactive programming? What about all these paradigms? Transactional programming. We saw functional programming. We didn't see lazy deterministic data flow programming. What about deterministic logic programming? There are lots and lots of paradigms. So what do? How can we understand this jungle of programming paradigms? In fact, the kernel language comes to the rescue here. Just as kernel languages let you understand the relationships between the different paradigms, we can use also the kernel languages to organize all the different paradigms. So one way of looking at a paradigm is a set of concepts organized as a kernel language, as a small core language containing all the important concepts of the paradigm. And an interesting point is that the kernel languages of different paradigms are related to each other. And it's very often true that two kernel languages differ in only one concept. So, for example, functional programming, we add cells, explicit state, and this allows us to define all the techniques of object-oriented programming. So these two paradigms, the kernel languages, have only one concept difference. So if we apply this principle in a thorough way by looking at as many paradigms as we can and defining them in terms of their kernel languages, we can organize kernel languages into a kind of family tree, where each paradigm with its kernel language is related to others, descends from others by adding concepts. So two paradigms are linked when they differ in exactly one concept. So we get a kind of family tree or a taxonomy of the different programming paradigms. So here is, for example, one taxonomy. So here the paradigms are organized in terms of the core concepts of the kernel language. So we start with a very simple one, which I call descriptive declarative program, just records, like basic HTML where you're not running any code, you're just describing things in terms of records. Now, if we add just procedures, no higher order, only first order, we get first order functional programming. And now we can keep going. If we add closures, which we call procedure value in this course, and we add single assignment since it keeps the functional property, we get a very important paradigm called functional programming, which we saw in this course, which is really a core paradigm because we can extend it in many different ways to get other paradigms. So here in this taxonomy, we have to the left the more declarative paradigms, and to the right the paradigms that are less declarative, the more imperative paradigms. So if when we add cells here, for example, we get sequential object-oriented programming, it's more to the right. Because we adding ports, message passing is more declarative, it's easier to program, it's slightly more to the left. And at the very, very left, we have logic programming, which is even more declarative than functional programming because we're really only describing properties of the result. So this, for example, leads to relational programming. This is a language called Prolog, which has been generalized to constraint programming. And then we have concurrent constraint programming, which goes even farther, and lazy concurrent constraint programming, which is the most expressive of the extremely declarative paradigms. Very interesting. I recommend you look at this. So how do our 5 paradigms fit into this? Well, in this diagram now, I have highlighted our 5 paradigms, the ones we saw in this course, in bold. So functional programming, multi-agent data flow, and then active object programming, which you can also call object capability programming, and sequential object-oriented programming. So of course there are many other paradigms we didn't see. We didn't see concurrent object-oriented programming. We didn't see lazy deterministic data flow programming. We didn't see any of the logic programming paradigms. But you can see that we did see 5 interesting paradigms here, interesting and important paradigms in this taxonomy.